Today's lesson objective is identify the relationship between the side lengths of a right triangle as the Pythagorean theorem and apply that relationship to solve problems. Specifically today we'll be solving word problems. So first we have our warm-up. And the Pythagorean theorem for right triangles only, you have a squared plus b squared equals c squared. And remember the length of the hypotenuse is c. It's the longest side. And then we have the two legs. Before we start, you always want to see if you can identify if it's a 3, 4, 5 triangle, a multiples of 3, multiples of 4, multiple of 5. And this one is not. This is a multiple of 5, and the 5 has to be the hypotenuse. So this is not a 3, 4, 5. So now we're going to go ahead and substitute for A. We have 5, so 5 squared. B, the other leg, 12, 12 squared. And the hypotenuse is unknown. So we have C squared. 5 squared is 5 multiplied by 5, which is 25. 12 squared is 144. Now we simplify, combine like terms. 144 plus 25 is 169. And that's what C squared equals. So we want to remove this exponent. So we're going to do the inverse of squaring, which is a square root. So we take the square root of both sides. This cancels out. And we have C equals the square root of 169, which simplifies to 13. For problem 1, Steve draws a triangle with sides 7 centimeters, 3 centimeters, and 6 centimeters. Is it a right triangle? Well, to determine if it's a right triangle, we're going to use Pythagorean theorem. And Pythagorean theorem states if a squared plus b squared equals c squared, then it is a right triangle. If a squared plus b squared does not equal c squared, then it is not a right triangle. So I was able to identify that 7 is the hypotenuse because remember, the hypotenuse is always the longest length. And it doesn't matter which one I identify as 3 or 6 for the legs. But just out of habit, I always use A as the shortest length, but it doesn't matter. So now I'm going to go ahead and substitute these values into the Pythagorean theorem. A is 3 squared, B is 6 squared, and C is 7 squared. 3 squared equals 9, 6 squared equals 36, 7 squared equals 49. And now we have 9 plus 36 equals 45. 45 does not equal 49, so that's a false statement. So this is not a right triangle. If this side equals 45 and we had 45 equals 45 and made a true statement, then it would be a right triangle. So it's not a right triangle. For problem 2, a triangle has sides 10, square root of 44, and 12. Is it a right triangle? Well, I need to approximate this value. And because I don't know, is this the hypotenuse? Is this the longest length? So what I'm going to do is I'm going to find the perfect square that's below square root of 44 and above square root of 44. And 6 and 7, square root of 36 is 6, square root of 49 is 7. So I know it's somewhere between 6 and 7. It's a little closer to 7, but I know it's somewhere in between 6 and 7, which makes it the shortest length. So it's shorter than 10 and shorter than 12. So I know 12 is going to be the hypotenuse. So I chose A as the square root of 44. And I'm going to go ahead and plug it in. A squared is the square root of 44. 10 squared equals 12 squared. Now here, since we're squaring the square root, those are inverse. Those undo each other. So the square root of a square will it just be 44? And then 10 squared is 100, 12 squared, 12 multiplied by 12, 144. Combine like terms, 44 plus 100 is 144. So 144 does equal 144. That's a true statement. So this is a right triangle. For problem 3, you're drawing a triangle with the sides 4, 5, and the square root of 40. Is it a right triangle? Well, again, I need to approximate this value to see which side it is, if it is the hypotenuse. So I'm going to find the perfect square above and below, and we have the square root of 36, square root of 49 is 7. So I know this value is between 6 and 7. So since I know it's between 6 and 7, I know it's greater than 4 and 5, so it must be the hypotenuse. So now I'm going to go ahead and plug these values in, and I chose A, just like I mentioned in the previous problems. It doesn't matter which leg you choose as A or B, but just out of habit, I choose the smallest value for A. So A squared plus B squared equals C squared. So I have 4 squared plus 5 squared equals the square root of 40 squared. And again, taking the square of a square root, those cancel each other out. They undo each other. They're inverse properties. And so 4 squared is 16, 25, 5 squared is 25, equals 40. Combine like terms, 16 plus 25 is 41, equals 40. Well, that is a false statement. That's not true. So this is not a right triangle. You're putting the base of a 12-foot ladder 6 feet away from a wall. How far up the wall will the ladder reach? So it's always good to draw a picture for word problems. So I have a ladder, and when I've seen students do this before, they couldn't figure out which one would be the hypotenuse, which one would be a leg. So, and I would have people do this. The ground would be vertical like this, and then the wall would be the hypotenuse. And or they would go like this and not really thinking about it. So remember, if you think ground is here, a wall is going to be vertical, and then you have a ladder up against the wall on the ground. So we have here we have a 12-foot ladder, and it's 6 feet away. So it's 6 feet away from the wall, and we need to find out, well, how far up the wall will the ladder reach? So we don't know how far this is. We do know that this is at a diagonal. This is our hypotenuse. So this is a right triangle. Right angle points to the hypotenuse. So we have the hypotenuse, which is the C. And I will call this A, or let's call this A. Again, it doesn't matter which one you call A or B. And this, so I'll call this leg A, this leg B, which has a value of 6. So A squared we don't know. B squared is 6 squared, and then the hypotenuse is 12. So 12 squared. Simplify, 6 squared is 36, 12 squared is 144. Inverse property of addition, we want to get A by itself, so it is subtraction. So we're going to subtract 36 from both sides of the equation. It creates a 0 pair. And now we have A squared equals 108. Now we want to do the inverse of squaring, which is the square root. So we take the square root of A squared. Those cancel each other out. What you do to one side, you do to the other. And we have the square root of 108. so A equals the square root of 108. That would be the exact value. Since this is not a perfect square, we can only approximate it. And if you put it in the calculator, you get approximately 10 and 4/10 feet. But if you're asked for the exact length, it would be the square root of 108 feet. Problem 5. A flagpole is 8 feet high. So here is our flagpole, and we know that this is going to be 8 feet high. It casts a shadow that is 6 feet long. So here is the shadow, and we know that it's going to be 8 feet tall and a 6-foot shadow. And what we're trying to do is find out what is the distance between the top of the flagpole and the top of the shadow. So here's where the shadow reaches. So we want to find this distance. And you should clearly see that this is the hypotenuse. And this creates a right angle. Flagpole is going to be vertical. The shadow is going to be horizontal on the ground. And we want to find out what the length of that is. So that's going to be C, the hypotenuse. So now we go ahead and plug it into the formula. A squared plus B squared equals C squared. So we have A squared. So 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared, 8 multiplied by 8 is 64. Combine like terms. 36 plus 64 is 100. Now we want to go ahead and take the square root to undo. The inverse property of squaring is taking the square root. So that cancels out. What you do to one side, you do to the other. And we get 10 equals C. So C equals 10 feet. So the length, the distance between the top of the pole and the top of the shadow is 10 feet. Problem number 6. You're flying a kite. The kite string is 30 feet long. The kite is 20 feet off the ground. How far are you from being underneath the kite? So what I would like you to do is to try this one on your own. Go ahead and pause the video and complete this problem. For problem number 6, you're flying a kite. The kite string is 30 feet long. So hopefully you drew a picture to help you organize your work. Here's the kite string that you're flying is 30 feet long, and the kite is 20 feet off of the ground. So to measure the height from the ground to the kite would just be straight up vertically. And how far are you from being underneath the kite? So here is the hypotenuse, and we'll call this leg A and this one B, but we have the value for it, which is 20 feet. So we're going to use Pythagorean Theorem. A squared plus B squared equals C squared. A, we don't know. B is 20, so 20 squared, and the hypotenuse is 30. 20 squared is 400. 30 squared is 900. We want to get A by itself. We want to isolate the variable, so we're going to do inverse of addition and subtraction. We're going to subtract 400 from both sides. 0 pair. 900 minus 400 is 500. Now we want to take the inverse of squaring, which is the square root. Those cancel each other out. What you do to one side, you do to the other. And we have A equals the square root of 500. So A would be the square root of 500 feet. That would be the exact value. Approximate would be 22 and 4/10 feet.